So for question 15, there's quite a bit of writing that we have to get through. So the first thing it says is that it's suggested that the three letters A, E and R are the most frequently used letters in the English language. 6 sentences were chosen at random from a newspaper article. The total of letters A, E and R in each sentence was recorded. So they've got that data in the table. And for example, sentence number 2, the total number of letters A, E and R was 6, and the total number of letters in the sentence was 22. Now, it's asked us, using all the information, to calculate the best estimate of the probability that a letter chosen at random from this article is one of the letters A, E or R. So, the best estimate is going to be if we can work out the total number of our letters A, E and R divided by the total number of letters in the whole sentence. Now, you could do it just for the sentence number 1 or just the sentence number 4. But to get the best estimate, what I'm going to do is add all of the total number of letters A, E and R from the sentences. So that is 8, add 6, add 8, add 3, add 4, add 5, which gives me 34. And I'm going to divide that by the total number of letters in my sentence. So 36, add 22, add 42, add 8, add 10, add 14. So put those numbers in your calculator and you should get 132. And so the probability that a letter chosen at random from this article is one of the letters A, E or R is 34 divided by 132. And if I work that out as a decimal, it gives me 0.2575 recurring, not recurring, but extending out decimal, which you could round to 2.6 to 2 decimal places. But you know that it's more accurate as a fraction, so I'd be inclined to keep it as a fraction. Now, for part B, that is worth 5 marks, so there's going to be a bit of work involved in this one. Now, we need to read part B carefully before we start to answer the question. So it says, all of the letters from the 6 sentences are placed in the bag. So that's all 132 letters. 2 letters are selected at random from the bag and not replaced. So that's important. Calculate the probability that at least one of the letters is a letter A, E or R. We've got to give our answer correct to 2 decimal places, and it does say that we must show our working, so if we don't, we're not going to pick up any marks. So, first of all of the letters from the 6 sentences are placed in a bag, so we know that there's 132 letters altogether. So if we wanted the probability of a success, so a success being that we pick a letter A, E or R. So we know that to pick a letter A, E or R, the probability is 34 over 132. I'm going to call the probability of your failure, so that's not picking a letter A, E or R, whatever's left over. So 132 take away 34 is 98. So the probability of us failing in picking an A, E or R is 98 out of 132. Now, it says for us to calculate the probability that at least one of the letters is a letter A, E or R. So, there are 2 ways that we can do this. If we think about the different ways that we could pick a letter A, E or R, so at least one of those letters is an A, E or R, then we could have where we pick a letter A, E or R with our first choice and with our second choice. So that probability is of 2 successes. We could have where we pick an A, E or R with our first one, but fail in our second attempt. And we could have it when we fail with our first attempt, but we manage to get it with our second attempt. So in each of those 3 cases, we've picked a letter A, E or R. So in order to work our answer, if we use that method, is the probability of a success and a success. Remember that we know that and means multiply. or means plus when we've got probability. So a success and a success would be 34 out of 132 times, now because it's not replaced, that means we've got one less tile, and we've got one less AERR. So one less AERR means we're down to 33, one less tile means we're down to 131. Now, we could have picked that one, or we can pick another one, so we're going to add this one on. So again, the success was 34 out of 132 with our first tile. But this time, we're going to have a failure with our second attempt. So there's still 98 not AERs available out of the remaining 131 tiles. Then our final choice, or our last OR, is OR if the probability of the first one is a failure and the second is a success. So that means that we've got 98 out of 131 with our first choice, and we're going to multiply that. We've still got 34 tiles in the bag that are AERR, and that is going to be over 131. Sorry, that previous one should be 132. So if we put each of these into our calculators, we should end up with our probabilities. Now I'm going to do each of them individually and then get a final answer, just to make sure that I don't make any miscalculations in the run up to my answer. Now I've ended up with these three values, and when I add those together, that gives me an answer of 0.4502, etc. So we know to two decimal places, that's just going to be 0.45. So the probability of getting at least one of the letters A or R is 0.45. Now I did say that there was an alternative method, so we're going to take a look at that now. So our alternative method, so we looked previously and said that there were three different ways we could get at least one letter. So the only other alternative that we've got is if we picked the probability of having a failure and a failure. So if we worked out that probability and took it away from 1, which is the certainty, we've only got 4 different possibilities, then that would leave us with at least the probability of at least one of the letters being an A, E or R. So if we do 1 minus the probability of them both not being A, E or R's, then that would also give us our answer. So if we work out what the probability of 2 failures would be, so that's 98 over 132 times 97, because we have one less tile, over 131. And so if we put that into our calculator, then we end up with 1 minus, so if we type in 98 over 132 and times that by 97 over 131, that gives us 1 minus 4,753 over 8,646. But if we do 1 minus our answer on the calculator, that gives us the same answer as we had using the other method, which we know to 2 decimal places was 0.45. So a little bit less work, but it did require our understanding to know that 1 minus the only other option, which is the probability of 2 failures, would give us the same as if we worked out the probability of 2 successes, a success and a failure and a success.